That is a new word.
It's linear in 4 different ways, so it doesn't know.
What do you remember about motion?
Motion.
Derivative.
Any direction.
Okay,
Physics.
derivatives. What about derivatives?
They tell you
Acceleration.
Oh,
The position.
Derivative of
ST.
position is velocity.
Vertical and
Okay,
horizontal
stop.
components
Jared
are-
said,
Derivative of position is velocity, and the derivative of velocity is acceleration.
And the derivative of acceleration is jerk. Bingo.
which I don't really care about.
Yeah.
But.
It doesn't.
The derivative of position is velocity.
Mhm.
The derivative of velocity is acceleration. Going backwards, the antiderivative of acceleration is
Position.
Plus C.
Velocity
velocity.
plus C.
Okay, the antiderivative of velocity, position.
Yes, plus C.
Minus C.
Okay, so we are going to apply that to vector valued function. Yeah, I forgot to do the clickers. I'm really sorry.
Can I answer right now?
Sure.
I'm answering for Jared and I. We average to A. I changed to my own scale. I've got A plus A.
Yeah, no average to
B
that
plus
kind of
A
thing.
minus, and then less than a B.
Okay, so turn it to the back.
Wow, that's
Hey, there's nothing on the back.
Where's the?
Ooh, I don't know.
Actually, no names on the other side. This is.
Okay, so we're going to talk about velocity and acceleration with our parametric curves, or really our vector value functions. So first of all, the derivative of x with respect to t is telling us how the x coordinate is changing. The derivative of y with respect to t tells us how the y coordinate is changing. Okay, because we're not just moving linearly, we're moving all over the place with our parametric curves. Okay, so we can talk about the x and the y coordinate changing simultaneously, as opposed to last year where we were just focused in one direction, right? Either back and forth or up and down, right? Okay. Okay, so if your vector is the position, the derivative is the velocity with respect to time, of course, and the derivative of that with respect to time is the acceleration. See those? Now, sometimes you'll see the vectors written with parentheses instead of the chevron. Thank you. Just kind of a side note for the AP problems that we'll do tomorrow. Dy dx is the rate of change of y with respect to x, or the slope of the tangent line on the curve of the position vector. Okay. The second derivative of y with respect to x is the rate of change of the slope. Okay, that hasn't changed. Okay. All right. So speed of the particle is the magnitude of the length. So you remember finding, we already talked about speed, right?
Yeah.
Okay. Well, if you look at that, it's basically just calculating the magnitude of the velocity vector. Crazy, because velocity and speed, okay, how are they related? Speed.
Directions.
Okay, velocity has direction, speed doesn't. Okay, so we calculate the length of that vector, and that gives us speed. Okay, and then of course you remember that when you take that speed calculation and you throw it in the integral, we're actually finding the arc length. Okay. So, and then of course you can work backwards. Okay. So let's get to it. Okay. We're going to go through 1, 2, 2 examples. Number 2 is really long. But we're going through 2 problems. Okay? So first of all, you probably want to write this down in a notebook. Probably not on your note sheet. Okay? A particle moves in the xy plane so that the x coordinate is modeled by this and the y coordinate modeled by this. Find the velocity vector at 1, the speed of the particle at 1, and the acceleration vector at t equals 1. When I say 1, it's t equals 1. Okay? So go ahead and write down your x of t and your y of t.
This isn't one of those we got. It's
No.
different. Gotcha.
Okay. How would we find the velocity vector? Okay, what's the derivative of x with respect to t?
3 t squared plus 18. Cubed minus 3t squared.
Okay.
Minus 1.
So at 1, what is our vector?
11.
Okay. B is our speed. Speed is just the magnitude of our velocity vector. Which can't be reduced.
But we can get somewhere near 11.
Just a tad bit more than 11. Okay. And then our acceleration vector would be what?
14.
Say,
Six.
Okay. Well, I first want to see what your acceleration vector is. Then I want it at 1, which would be the 14.
what's the magnitude of the acceleration?
196.
What does it represent?
I don't know.
Oh, is that what you're asking?
Yes.
No.
Square root of 232.
Thank you.
Okay.
Does it mean
Does it-
anything? No. Okay.
Okay, so what am I going to do here is...
Let's make this be the test.
Can this be a Rachel?
Just this.
2 squared.
Okay, and then t to the 4th. Why isn't it showing anything?
You didn't click the add button.
Whoa.
Where did you mean? I like that graph.
Oh, it has to be an S, that's why.
Food plot.
Yeah.
Why
Yeah.
not?
Wait, so is it not going to be that
Why not
cool?
Desmo? Desmo doesn't do parametrics.
No.
Aww.
What?
The other one is so much cooler.
Okay.
So much cooler.
The other one like polar or something?
Sorry to disappoint. Well, it's
Yeah, how about we do a problem like that one?
Rose petals?
after winter break, we will do polar. And you'll even get to do a polar project where you get to design your little picture
polar bear?
with polar equations.
I'm gonna make polar bear.
Okay.
It's about 11.05, guys.
So where are we when we're talking about T is 1?
Oh, T is 1, we're at
5, number 0.
Wait,
Yeah.
0,
At 0.
right there.
Right there. So that is where our velocity vector is 11,1. Our speed is square root of 122, and our acceleration vector is 14,6.
It's going like clockwise. Is that T? Wait. No.
No.
No. Counterclockwise. Is that T 0?
If you
Yeah,
can-
which would make sense that our velocity and acceleration are like that, right? If your velocity vector is going that way, it would make sense that, right?
Is that another way that you can find like the arrows? Like instead of plugging like T0 into your T is 1, you just find a derivative and see like which direction it's going. I mean, you found at one point, and then we know it's like 11,1, so it's going that way. So velocity is going that way. You find the arrow.
Well, the velocity is decreasing with
We
time.
can graph the derivative and see.
The velocity is decreasing with time, while the acceleration is going with time, so.
But he's asking about the velocity though. If the velocity, it should be going in the direction of velocity to a certain extent, right?
We can check.
Unless it's slowing down.
I'll think about that one. Okay, if you want to text it out on a few different points on a nice easy graph. That'd be. Right now, my mind says, yes, I think that should work. Let me think about it a little bit, okay? Where's my blue?
Sean probably stole it.
It's right
Doesn't
here.
like his technicolors.
Wait. That was all in blue.
Go
It's in your hand.
I found it. It was on my desk. It wasn't in my hand when I asked where it was. Okay. An object moving along a curve in the xy plane at the time t. Now I'm giving you dx dt and dy dt. At time 2, the position is 1, 4.
And acceleration. Oh, acceleration.
Okay? I'm giving you time to write down the equations and the initial condition. If you so choose to write these down and do the example with us. Take your acceleration now.
We have to plug into
The
2.
derivative formula.
That's gonna be nasty. Calculator, yeah, you get a calculator. It says
Hey.
at the top left.
Do the
Perfect.
Okay. So, yes, this is with your calculator. So let's remember how to take the derivative.
At a point, math 9.
No, math
Math
8.
eight.
Math 9 is the integral.
I knew it was one of those.
They're very
Math
different.
7? It's math 7.
Oh, wait,
Math 7 is the max.
Ooh, you can find the maximum?
Yeah.
T sine t.
Like, derivatives equals 0 maximum?
X.
Well, that's not a maximum.
X equals
It's possible.
2 mode, wait, mode, radians,
I know, it's like
like 0,
It's like
Or something.
infinitesimal small number out of the, out
Zero,
of the
seven,
infinite
seven.
number of
Um,
possible.
0, 7, 7, right?
Nope.
Yeah,
exactly.
it's not like that.
Would be X.
Squared. 2. Okay, that's interesting. 0.
Got like 2.0.
Wait, what did you say?
2.02368 for this one.
Hey,
I don't know, am I doing that wrong?
Are you in radians?
Double check. Oh, I am in degrees.
Okay, perfect.
What'd you get?
.0770.
Yes, 0.077 and then 3.027. Yeah.
.027.
The curve point where
Wait. Raising contingent
it's not bad.
Wow.
Okay. So now, everyone getting these in our acceleration vector? We can work our calculators. Now we want to write the equation of the tangent line to the curve or the point where t equals 2. So tangent line means we need what?
Slope.
And?
A point.
Okay. So slope.
Hey.
How are we going to find slope?
Wait, of which curve are we writing?
Negative. 2 point.
Of which what?
The original.
The original curve.
Negative 2.78.
So to find slope, we need dy dt over dx dt. And we need to evaluate it at t equals 2. Right? Isn't it negative?
Yeah, negative 0.359.
Make sure you can get that. Check Andrew, please. Andrew has been known to be wrong before.
I want to be right. I don't try to.
Well, I would hope that you would not try to get that wrong.
Yeah, that would be silly.
You can't do this in your head.
I would even look at that stuff. I don't know.
He's right.
Okay, you got it. We can move on.
Okay? So that's our slope. What's our point?
That one will take me a minute because I
Plug
have
it
to
in.
do,
Well, our point is 1/4.
Yes.
Because they gave it to us.
Yes.
So, y minus 4 equals negative 0.359 times x minus 1.
Yeah.
You can get smiley face.
I got smiley face.
Yeah, we got smiley face.
Ooh,
Really happy.
super smiley face.
Yeah.
Instead of
Now I want the speed of the vector at t equals 2. How do we do that?
Velocity stuff.
Velocity squared, velocity
Plug it in.
squared, all square rooted.
So the square root of
2
2
sine
sine 2 squared.
dx dt evaluated at 2 squared plus dy dt evaluated at 2 squared.
3.02.
Can you take the square root? Nathan, can you take the square root?
Oh, I'm computing accelerations.
Oh, gotcha. Is 1.932? 1.932.
One second.
1.32.
I don't want you to be the only one doing the work in your calculator. That is not how we learn.
Team effort.
Displacement. That's different.
Ooh,
This
that's
curve.
area under the curve. No.
Oh,
Multiple
it's the
times,
magnitude of the position.
times velocity.
Magnitude of the
Is velocity constant?
It's the magnitude of the position. I believe.
Yeah. Wait, no, we take the integral thing.
Yeah.
Oh, yeah, to find position. No, we
No.
have position.
Displacement
magnitude of the position.
Area under the curve.
is area under the curve. So we need to take the integral from 2 to 7 of t sine t dt. The integral from 2 to 7
We're good.
of cosine t squared d.
Should we calculate do? Oh, wait.
We're gonna have to do 2 separate integrals.
And then we find the magnitude.
Why? Displacement, not distance.
Oh,
Displacement is,
Has a direction.
don't ever sing this. Okay, so my son really likes the Madagascar movies, so he has them recorded. And there's that circus one.
Yeah.
You know what I'm talking about?
Afro
Yeah,
circus?
that-
Yeah. Yep,
I can pull up YouTube videos and for free.
I know. No, we watched it. Numerous times.
Oh, I'm sorry.
Negative
We'll fly this stuff out.
6.362.
Negative what?
6.362.
Yep.
969.
Okay, so that's the displacement. Now, how would we find the distance traveled?
That's when we do
This one's on the back of the
absolute
sheet.
value of unique equation for
Like an arc length.
arc, yeah.
Arc length.
Oh, this is the
The thing we get our chapter.
Please give me a
Yeah.
second. This one will take some time.
Oh, is this?
I thought it was 1 plus.
What do you mean, man? You're an arc length? Yeah.
Yes, we
For
are.
distance traveled?
I thought our length was pi,
Wait,
integral square
Why
root
is
1
the
plus
other-
dy.
That's when we have a function in
Man.
the,
oh, we not
That's a
square.
good-
this is parametric.
Oh.
It's the absolute
It's
value.
like cosine squared squared.
Right.
Is in the,
Oh, sorry.
Yeah.
you forgot the square.
Yeah.
Is it 13?
Because like
Squared
cosine
squared.
9.
squared. But yeah,
Yep.
And the position.
Yeah, I guess you
part
don't
of the
actually
time
know
t.
the value.
No, because it's arc length, so it's gonna be,
Yeah.
okay?
Really, I'm a.
Wait, what's the square root? I get this? Still value.
Okay, are we getting that? Probably not, what?
please just.
Here, should I ask? Thank you. Okay, now we want the position of the particle at time t.
This is also on the back.
Okay. Okay, we know velocity, how do we get to position?
Anti-derived.
Okay,
Just one question, what was that point again?
1-4.
okay, so if we remember back to the fundamental theorem of calculus, we know that the integral from 1 to 2 of our velocity should equal our position at 2 minus our position at 1. Okay.
Yes.
So that minus. Maybe we'll put your confusion back. I forgot this question, so
Would it be negative 0.440 minus 4.440?
Okay, so if your last name begins with A through N, you're finding me the X. If your last name doesn't, you're finding me the Y.
Okay, finding the x, we're good.
Okay, got it.
Okay.
Shoot it.
Well done.
Then we'll be able to use it when we get to.
Not all of our problems are calculator problems.
Mine doesn't think. It's just silly.
Yeah.
But not all.
Cool.
Really clear excuse to. If it has juice, you can use it.
Good merge.
Wait, so at G equals 2, we're at 1, 4, right?
Yeah.
Okay.
A through N. What is our X coordinate?
0.440422.
Last half of the alphabet.
This one, Jared.
Yeah, 4.443. 06.
Did you take 1 minus this?
Oh, because it's negative flips, okay. No, no.
Because
no,
we
then-
know that position at 2, we're finding the
no,
position at 1.
I see what I did.
Okay.
I can subtract the 1, but it's negative S, so it's tricky math.
All right, so the back side is your homework. Please pay attention to whether it says calculator or not. So only 10 through 13 you're supposed to use your calculator with.